Now let's try crypt-analysis. As we learned, the difference between the decryption function, the function for crypt-analysis, is whether we are given the secret key K or not. For example, here we want to decode the ciphertext without knowing these three. Yes, you may ask whether it is possible. It's generally difficult, but it's feasible under the condition that the ciphertext is relatively long English text encrypted with Caesar cipher. You can get a hint by taking a look at, for example, one of the famous detective novels of Sherlock Holmes by Arthur Conan Doyle, titled The Adventure of the Dancing Man. It would be helpful to take a look at the book and consider the best approach. Let's skip ahead a little. This is in fact an example outline of crypt-analysis program. Let's name it crypt-analysis.rb. By comparing this program with the program for decryption, you can see what I said more concretely. That is, the difference is while we need to compute the secret key K from a given ciphertext, K is already given in the program as a secret information. Once the key K, in other words, how many letters to shift by, is determined, we can use the decryption function, or more precisely, this subroutine that computes it to decode the text. Let's consider how to compute K. For example, let's assume we are given a ciphertext like this. We don't know what it says. Let's count the frequency each character in the text. That is, how many times each character appears in the text. For example, we will create this array. Let's call it a frequency array, and let's name it FREQ, F-R-E-Q. This array is for counting how many times the various characters appear in this ciphertext. Here, indices of the array correspond to the distance from a letter A in order. That is, the letter A corresponds to index 0, B corresponds to 1, and so on, until the last letter Z, that corresponds to index 25. Recall that the codes for these lowercase English letters go in order, starting from A. Thus, the index of each letter is nothing but distance of the letter from A, or more specifically, the difference of its code and the code of the letter A. So let's consider a program of counting how many times each letter appears in the ciphertext and keeping it in the corresponding place in the array FREQ. This counting is like drawing tally marks. Draw a bar when you say the letter B appears. Then draw another bar if it appears again, like drawing tally marks. Let me give an example outline of this counting program. First, let's store the code of A in a variable like usual. Then let's read the ciphertext into the array, or a string variable called ciphertext. For example, we will read this kind of string. Now let's calculate a read string using command length and store it in the variable len. Then we will unpack the ciphertext and put it in the array AA. That is, AA is the array keeping the codes of characters in the ciphertext in the order they appear. Then we will arrange array FREQ that expresses the frequency. Since there are 26 lowercase English letters, the length of array is 26. Let's set the initial value to 0. Then, looking at the letters encoded one by one from the array AA, we revise the number of occurrences of each letter. This for loop is for this computation. For each ith character of the ciphertext, we calculate its distance from the alphabet letter A and place this distance in variable diff. Then we just need to update the value of the frequency array with this index. Let's think about how best to update them in our practice exercise. For example, let's assume we succeeded making this program, and by counting the frequency on this ciphertext, we learned that H appears most often. In fact, in this example, H does appear 24 times, which is the most. Considering only lowercase letters, the letter of the alphabet that appears most often in English is E. For example, using a graph taken from Wikipedia, we can see from the large amount of data that the frequency of E is very large here. Note that the difference from the second or the third best is quite large. That means that it's plausible that since H appears 24 times, H might actually correspond to E. The distance of H from the code A is 7. In other words, H is in the 7th position from A, or the index of H is 7. Furthermore, counting from A, the index of E is actually 4. Let's check it. The index of A is 0. The position of A is 0. The index of B is 1, which is the distance from A. And the index of C is 2, and then D is 3, and the index of E is 4. This means the letter in the 4th index should have appeared most frequently, but H, 7th index, appeared most frequently in this ciphertext. That is, E at the index 4 is shifted to the 7. Then we can consider that the letters are shifted by 3. That is, K is 3. Okay? We looked at what appears most often, then accordingly find how far its position is from A in the alphabet. If it should have been E, then the distance is 4. But in this example, the distance is 7, which tells us the letter was shifted by 3 to create this ciphertext. Let me wrap up. For the crypt-analysis, we need to compute the secret key K. For this, first for a given ciphertext and for each character, its frequency or the number of times that it appears in the ciphertext is calculated. Then compute the most frequently appearing character and its index. For example, in the variable max_diff. We earlier studied a way to find the highest number within the array. We were also able to compute its location. Here it is, this variable. We put this information in this variable. On the other hand, diff of E is 4, so the difference between max_diff and the diff tells you the K. So we can calculate K from these two values. Let's consider this calculation more precisely in the exercise.